Thanks, Nebrisha, for the opportunity to be present at this event today and to present what AST has to offer in the area of cybersecurity. Good day, everybody. So, when it comes to AST, the company, as I already mentioned, this is a vendor company. We have an area of cybersecurity products. And the topic of today's presentation will be the first one that you see here in this list is the tactical threat intelligence. So you will hear during my presentation today many different phrases. They are all interrelated, like traps, threat intelligence, tactical threat intelligence, digital clones, TI platform. So this is all part of the same story. Besides the products, we also have a services portfolio. And what is interesting about this portfolio is that we are providing the Security Operations Center services based on 100% technology stack based on AST technology. The security operations, penetration testing, and the other services, this is all tightly coupled with the Security Operations Center stuff. But today, the main topic is tactical threat intelligence. If there is any interest in the services part, please talk to Nebrisha. He will organize that we also can tell you a little bit more about that. Now, the motivation. So why are we doing what we are doing and what we are trying to achieve? When it comes to cyber attacks, usually one of the main, let's say, ingredients of a cyber attack, it's a security vulnerability in some software. And the, let's say, life cycle of security vulnerability or security exploit looks like this. So at some point in time, some researcher finds a security vulnerability in some code. Sometimes they try to talk to the vendor directly and to get their attention in order to fix this, maybe to sell it, maybe to, to give it for free. Some vendors are receptive to this, some are not. Some respond more or less quickly, some do not. At some point in time, this vulnerability gets published. The moment the whole world learns about this vulnerability is through the CVE news, so it's the Common Vulnerability Database entry. And from this moment on, we know that such vulnerability exists. From this moment, actually, we refer to all attacks related to this vulnerability as zero-day attacks. This graph here shows that the tendency is clear, that the number of discovered vulnerabilities and published vulnerabilities is only going to increase over time. When it comes to zero-day attacks, this is a very nasty thing because, as I already mentioned, zero-day attack means that we are dealing with attacks that are exploiting vulnerabilities for which a vendor patch or fix does not yet exist. So we have a certain time frame when systems are extremely vulnerable to this kind of attacks. And one extreme example is, of course, the Log4j. It happened some 2 years ago. Why this example is so interesting is because it had huge impact on security of information systems, so corporate networks and so on. The piece of code in which the vulnerability existed actually turned out to be, as this screen here says, part of more than 1,000, almost 1,500 different products. So while usually when you have a vulnerability, it takes some time that the vendor fixes this vulnerability, issues a patch, then everybody who is using related product downloads the patch, installs it, and everything is perfect from that moment. Here we had a situation that this specific vulnerability affected a huge number of different systems. It means that, again, a huge number of vendors had to update their own systems in order for this problem to go away. And this took a long time. I'm not even sure that it has finished to this day. So zero-day attacks are especially dangerous things because they refer to attacks that the systems cannot be protected from until some patch or workaround is issued from the vendor. So this is the what is really the big problem today in security in the world. Now, how do we approach solving this problem? I have here 2 slides. These are screenshots from a nice animation video. I think I will share this link with Nebusha. It may be interesting for you to take a look. It describes in a very interesting, funny way what we do, and I will here just try to explain it in a few words. So the picture here, let's say, represents how your perimeter, your corporate network could look like, to the attacker from the internet. And this is the perfect situation when you have huge resources. You can afford to get all these small green men in front of the castle, which are symbolizing, perfect protection of the perimeter. Nothing can get through. Then you don't have any unlocked doors, broken windows. You even have some monitoring systems, and so on. So this is the perfect situation that you can have. More often than not, situation looks much more like this. So it's the protection is there or it's not there at all, and practically the attacker can choose the way to penetrate the network. Now, what usually comes to mind when talking about this part is probably most of you know the anecdote about the bear, right? So in order not to be eaten by the bear, you don't have to run faster than the bear. Yeah, you just have to run faster than the guy next to you. So this is the sad truth also when it comes to vulnerabilities and security on internet. Unless it is about a targeted attack, which is a separate story. If you are better protected than most of the corporations on the internet, you have much lower risk to be attacked. But there are also, this is when it comes to targeted attacks. When it comes to, some general type of attacks, no one is protected anymore, especially after all the encryptors appeared. So no one is safe anymore. Now, how we try to protect our clients? What you see here, so let's say that the blue dots here, these are our clients. These are all some resources on the internet. Let's say some cells of some organism, or let's say some systems on the internet. The blue ones, these are our clients, which we are protecting. The green ones, these are all other systems that exist out there which are not using our services. And on the left side here, we see this small red thing. This is some infected cell, right? So this is a breach system, and all the threats that it represents. From this infection or attack can spread, to the next system and so on. But the approach that we are using so-called traps, or digital clones. These are, let's say, replicas of regular information systems, and they are hidden somewhere here among these small red guys. So attackers sooner or later start attacking also our traps. The moment this happens, now we are shifting to the right-hand side of the picture. The moment this happens, we analyze these attacks in real time. We figure out what is going on, how to protect ourselves from this, and this information is then propagated to all the blue guys. Blue guys are again our clients, and they will automatically get immune, let's say, to this kind of attack. So this is, let's say, in more or less medical terms, what we are doing. I will go now more and more into details. It will become clearer. So after this slide, I will switch to the live demonstration. So I will show you how the real system looks like, and I'll show you how this works. But for now, I will start with the first building block of the solution. These are the digital clones, or the traps. Very often people ask us, okay, are these honeypots? The answer is no, this is not a honeypot. The goal is the same, right? So both the honeypot and our traps, they have a goal to attract the attack. But what we do and how we do it is that our traps are unique in a way that they are created as a clone of the real IT systems on the internet. So they are not, there is no signature of these clones that you can use and recognize our traps in advance, which is usually the case with honeypots. And also, they are not just there as a decoy. So it's something that should attract attention and take the attention of the attacker away from the real resources. Our traps are built in a way that they analyze the attacks that are coming, and they are sending all this information to the backend engine, which is in real time processing this information. So I will now stop the presentation for a second, and I will go to our system. So tell me, please, if you can see some black screen with AST in the left upper corner and some strange text in the middle.
Yeah, we see it.
Yes. Okay, so what I'm showing you now, this is the web console. This is the interface to the back-end analytical engine, which is gathering information from all the traps that we have deployed all around the world. So this screen is not really for today's presentation. What you see here, this is the content of the events that it is receiving, but I will go to something that is more comprehensible and more interesting. So now what you should be seeing on the screen, it's a world map. We call this real-time map, and you see a lot of red dots there. Now every 10 seconds, the information on the screen will be updated, and it will be showing new attacks that we are seeing right now on our traps infrastructure. The red dots are showing geolocation of where the attacks are coming from. Now, we can also show on this map different things. We can also show the attacked traps and so on. But now we concentrate for this moment on the sources of the attack. And you see in this scrolling table on the right, you see the IP addresses and you see the countries from which the attacks we are seeing right now are coming. So again, we have the ecosystem of traps all over the world. They are in real time receiving the attacks, getting attacked, analyzing this, sending the information back to our backend system. And what you see here, this is the information presented from this database of information about the attacks. This interface is and the analytical engine is quite powerful. I will just show you a few dashboards, a few screens, so that you get a feeling of what is going on here. So, okay, I'll try to magnify this. Can you see it properly?
Yes, we see it.
Mm-hmm. Thanks. Okay, so here this is about the. Again?
I'm just joking because it's not easy to read.
Yes. Okay, it's not easy to read. What you see here, these are payloads that we are receiving through the different GET requests, POST requests, and so on and so on. And the payload is not easy to read. There are some, at least it's not easy to read for us, right? So we have guys who are very good at this, but this needs analysis. I will see if there is. Yeah. So sometimes these payloads are encoded, sometimes not. Yes, it's not easy to read. The one that I see on the right, but on the other hand, when it comes to analytics, this is like a gold mine for guys who are analyzing the attacks, because they see exactly how the attack is going on, which parameters are being sent, and so on. Imagine like this: you're a client who has, for example, I don't know, internet banking system, which is available, accessible from internet. What we can do for you is we can make a clone of your system. So it will be another virtual machine, which we will put right next to your system with a similar IP address, so in the same IP segment. So what will happen in the real world? The bad guys, yes, they are attacking the real systems that exist on the internet, but more often they are trying to find systems which are not published. For example, and this happens very often. IT guys will put something to be tested on the perimeter. It's accessible from internet. Then they will forget about it. They will not patch it, and it will stay there for years. So what the hackers are usually doing, they are of course scanning your network. They are trying to find if there is anything else except, for example, this online banking system, which may be worse protected than the online system. Because if it's an online system, maybe there will be web application firewall, there will be other means of protection. So we put this right next to it. The attackers see that this thing exists, and as soon as they start attacking this parallel system, we know that this is not with good intentions, because regular users, they will end up on the real online banking system. They will not even know that there is something on the IP address next to it. The only guys that will know is those who are looking for something next to it. Remember that castle that I was showing you, right? So if you leave some door at the back open, no customer, if you have on the front, for example, a store, all the customers will be coming to the front door because they have nothing to look for in the back. If you leave a back door or back window open, most likely it will be someone with bad intentions that will end up there. Same thing here. So it's a very simple principle. We put this trap there, and once the bad guys start attacking it, we immediately know where they are coming from, how they are attacking your system, and this information, the one that we cannot read easily here, it is real gold for the developers, for the security guys, because they will get very detailed, the precise information about how the system is being attacked. And this can be, maybe there is already some vulnerability there, and this is very valuable for the developers, for the IT guys, security guys, who are protecting the system, and so on. But for us, what we see here on the right side is much more readable. Right? So this is information dashboard which shows the brute force attack on some authentication system on the traps, and you see here a lot of, this is easy to read, a lot of usernames, passwords, and so on. So actually, what you can do, you can build your own dictionary of real life passwords and usernames that are used by the bad guys to breach the systems. This is one thing. One other thing, how this is used, very often when there are some leaked databases. I don't know, a few years ago, it was from LinkedIn, then from many different, very popular services, and sometimes people are using email addresses of, corporate email addresses, for example, as credentials on these systems, and people are people. They usually also reuse the passwords, and how this happens in real life is that if the attacker finds in these leaked databases of credentials some credentials that may refer to your company, they will at least know the username. So they will take this username and try some brute force attack with this username. When we are following what is going on our traps exactly placed at this client's perimeter, we can see if there are real account names being used for the breach. And then we can warn the client and say, okay, here is a list of the accounts that is actively being, brute forced on our trap. Please make sure that these accounts are either invalid or that the passwords are, changed, because it may be that they will be, breached in the near time. So this is like early warning for the brute force attacks. There are also here HTTP requests, but okay, let me go a little bit further. This web console and the application, it's actually created for the analysts. It has a lot of different mechanisms for different correlation of attributes, of parameters in all this information that is coming from the traps. We'll not go through all this. This is too complex for our today's session. Also, in real time, we can identify the URLs that were never seen before, for example, or some aggressive attacks aggressive in the sense of number of contacts, you know, or we can also identify some email address, IP addresses, which we do not see in most of the third-party threat intelligence feeds. So quite unique IP addresses, and this happens all the time, you know. So we can when we see the mostly used IP addresses in the attacks to our Traps ecosystem, very often we see that most common, most famous threat databases do not know about these IP addresses. And I will come back to this a little bit later when I talk about the effectiveness of the solution. Okay, I will stop here. If there are any questions, feel free to interrupt. If not, I will continue with the PowerPoint.
I'm checking in the chat. Nothing in the chat of questions.
Okay.
So here is a question in the chat. Let me check it. Okay. Usually, an application is built with several parts, so it's not really clear how do you manage to make a clone of it. And
yes,
yeah,
I will get to that. Sorry.
It's a good question. Good question.
Yes, I agree. I will get to that right now. There are a few building blocks. The first building block is actually the cloning, right? And the cloning, it's not a simple process. It's actually the core of our intellectual property. This a patent for this has been filed, and the way it works, there are actually two modes how we can do this. Let's say a lower level cloning we can do without any credentials. For example, if we are talking about some, as I said, internet banking application. So now I'm talking about more complex ones. We have a lot of clones, and we can also clone simpler devices like IoT devices. Actually, we are cloning their web interfaces, right? So, or admin consoles of some, I don't know, routers and so on. But what is most complex, it's actually the web applications. And what we do, we scan this application from the outside. So in order for this process to take place, there is nothing that is needed from the client. We do this completely, transparently from internet. But then we can only go as deep, So if there is authentication, then if we want to also go through this level of cloning, we need to get credentials from the client. So we need to be able to log in to the system. And what we are doing, we are actually training our system to respond in a certain way to different requests. So after the cloning process is finished, you have a virtual machine which has two functions. The one function that is available from the outside, when the attacker starts interacting with this trap, either, for example, we usually demonstrate this through a browser. You can surf through this web application or website. It will give you all the pages and so on and so on. Also, when it comes to automated requests, it will handle this very similarly to the original application. There are some nuisances here because there is dynamic information and so on and so on. So the clone has a possibility to either show you the response that would be a unique response, original response from the real service, or it can create some response that will be believable enough that the attacker does not figure out that this is not a real system. But during all this time, there is a second function that exists in the background. We are logging everything that is happening. So all the requests that we are getting, and they are being sent to this backend for analysis. So the process of cloning is not simple, but the results we have at the moment is that it is very difficult to figure out that this is a clone, and we are able to keep the attackers long enough, messing with this clone so that we can figure out what he's doing, how he's doing. Now back to the presentation. So this actually the traps ecosystem. This would refer to the left side of the slide. In the middle, we have this small brain, let's say, and this is the logic and the analytics that exist on the backend system. We have just seen the window to this information or to this data through the web console that I was demonstrating. And now how all this comes into play. On the right side, you have different security solutions. It can be firewalls, it can be SIEM systems, it can be EDR, whatever. So we are generating on the threat intelligence platform, threat intelligence feed, which is being sent to all these devices. So we are practically gathering a lot of information about the attacks from the whole, let's say, from internet. We are doing this in real time. We are also processing this very fast and generating practically in real time updates to the threat feeds that we are sending out to our clients. So as soon as some trap anywhere in the world is being attacked, this information very quickly ends up in our backend and is distributed to all our clients so they can be protected from this specific IP address or from this specific type of attack. Yes, the analytical engine and the web console, this I have already shown. If there are any questions regarding the technology, we can still come back to this later. Now I want to change the perspective a little bit and talk about this from the, let's say, product perspective, client perspective, and so on. So once more, the building blocks. So some of these phrases you will hear a few times from different angles, so that I'm hoping that I will be able to cover, whole possible context, so that each of you can pick the one that is close to you, that is familiar to you, and understand exactly what we are offering. So clones. What we do is we clone the services of our clients, or we are putting their already created digital clones, and we are expanding our ecosystem of traps. This is used to gather in real time the information about attacks. Then our threat intelligence platform is generating feeds based on this, and these feeds can be sent to firewalls, EDRs, and so on. Why our threat intelligence is so effective, and I will show you this a little bit later in real figures, is because it is tailored to each of our clients. So we are putting the traps to this specific client's DMZ or external perimeter, and we are receiving and analyzing the attacks that are happening to this very client. So we are not trying to protect him with information that is, relevant for different parts of the world or different organizations and so on. We are adding to this threat intelligence feed also information that relates to this specific client. And also, by using this approach and some additional things that I will talk a little later, we are also able to protect ourselves and our clients from things like unknown types of attacks or zero-day attacks. So this is what we are offering. Now, when it comes to client advantages, so we have real-time prevention of the attacks, unknown and zero-day attacks as well. This is very easily integrated into third-party solutions. For example, when it comes to perimeter firewalls, most of the modern firewalls, they have very, easy to configure interface where you can configure. Usually, it is called third-party threat intelligence. We just give you certain parameters. You configure this. It will take 10-15 minutes, and you're ready to go. You can update and fetch the information from our platform as often as you wish, while most of the vendors are doing this once a day or even more rarely. We can do this practically, as often as your firewall can handle it, because very often these perimeter firewalls are working under very heavy load, and then they don't want to risk putting additional load, and they update this once in a day or once in a couple of hours. But we are actually providing this information real time. You can update, every 15 minutes, every 5 minutes if you want. When it comes to this solution, it does not require, if a client is buying this solution, it will be very easily integrated into the perimeter firewall, for example. And from that moment on, the protection is working. So you do not need any additional people who will be maintaining this. You configured it once and that's it. Most that you would want to do is, get the statistics from time to time and see how well this is doing. That's it. For some specific projects, we are also ready to provide the possibility for a source code review. For example, it can be some government institutions and so on, or a source code deposit, or even white labeling. So these are the advantages that the client gets. Now, when it comes to how unique this offering is, firstly, yes, as I already explained, the traps are unique. So we are not aware of any other potential competitor in the market that is doing something similar. Consequently, the attacks that we are analyzing, this is the real-time analysis of attacks that are happening with the client right now. So this is also quite unique. There are, of course, some network level devices like IDSs, IPSs, like network traffic analyzers and so on, which can do very deep packet inspection and analysis of the traffic. But due to extremely high load that exists on the perimeter, no one does this. So no one puts this kind of analysis outside of the perimeter. They usually put it inside if something gets through, that this is thoroughly analyzed. But the concept that we are applying, it allows us to do this, or let's say a part of this that is valuable, that we do it outside of the perimeter. Customer-specific threat protection, this is I already explained. So due to the fact that we are using the traps in client's perimeter, we can customize the protection and protect from exactly what needs to be protected. Now, if we expand this a little bit, and for example, within some country, we have a number of traps deployed, I don't know, 10, 15, already we can quite well grasp the, let's say, the specifics of the attacks that are happening in some country or to some country. And this is what we call national threat intelligence. So this is also very interesting, for example, for some government organizations or some big vendors which have presence all over the country. With our technology, they can actually get insight into what is specific to the attacks happening exactly to them on the national level. And of course, again, also one of the differentiators is possibility to detect unknown attacks, zero-day attacks, targeted attacks. Now, when it comes to sales cycle and the business model, what we offer to our partners as a support during the sales cycle is, of course, the initial presentations and demonstrations. Then the main step in the sales cycle is convincing the client to do a pilot. Because so far we did not have a situation where the client agrees to a pilot and does not buy the solution later, because the pilot is free and it very clearly shows the effectiveness of the solution. This will be a subject of my next few slides. How the pilot looks like is the following. So the client provides for us one or a few virtual machines. A little bit later, I will show the requirements. They are quite modest. And we deploy either the standard digital clones, or we clone one of their services. And this is called customer-specific digital clone. We leave this to just stand there for a week or two. This is quite enough that we gather enough information that we can give the first presentation to the client and show him, what is going on his perimeter. And this is very often, very interesting for the client, because there are at the beginning questions like, okay, why do you think that if you put the trap at the perimeter that anyone will care and anyone will be attacking, right? So you can spend a lot of time convincing the client that this will be the case, but most, much easier way is just to put the trap there and to show him what is going on. So what you usually see on the traps, it's two types of things. It's either random scanning of internet. There are vulnerabilities, different services, so different bad guys on internet, they have exploits for these vulnerabilities, and they're just looking randomly to find somewhere these services so they can exploit it, get hold of the system, and then try to monetize this in some way. Or there is a targeted attack. If we are seeing some kind of attacks on your traps only in your perimeter, and we are not seeing it anywhere else, so this is a clear definition of the targeted attack. So when we put the traps, already after a week or two, we can show some analytics to the client. Next phase is to integrate the threat intelligence feed to their perimeter firewall so that the real protection can be put in place. And then we can do the second or the only presentation at the end of this process, where we will show the statistics about the attacks and also the statistics about the effectiveness of the solution. And of course, if the client needs this kind of support, we can help with defining the requirements, RFI, RFP, and so on during the procurement process. At the end of the day, of course, we do the implementation and maintenance of the service. Now, when it comes to the business model, we offer a revenue sharing model. So this gives quite a lot of flexibility to our partners to adjust the solution to every client, right? And this goes hand in hand with scalable price range because we can deploy different number and different types of traps to their DMZ or their perimeter. If it's a big company, they will have a lot of different network segments. They will have presence in different parts of the world. Then adequately, and the type of traps should be adjusted to this. So it will not be 1-2 traps. It will be more. When it comes to threat intelligence feed that we are providing, there are also different levels of protection there. So we can generate the feed based on attack information which are coming only from the traps belonging to this client. This is the basic level. It will already give significant protection. Then there is the next level. We already discussed it as a national level, let's say threat intelligence, or we can send the client the feed based on attacks to the whole traps infrastructure that we have. And as the most complete feed, it's what we call a global feed. It will contain all the indicators of attack from the traps ecosystem, plus additional information based on open source intelligence, based on our research, and so on. For the very specific clients, we do also custom projects where we can include some other of our services as well. Here are just a few illustrations. So after the trap is deployed, already after a few days, we usually try to make it at least 2 weeks to come to some stable situation. But what we usually see, here in yellow, and on the left side, you will see also the numbers that are corresponding to this yellow line. Usually on a single trap, we see 100 or more different IP addresses every day. When it comes to number of contacts on interactions or number of attacks, this goes into thousands or tens of thousands. So on that first presentation during the pilot, we usually show this data and we show the result of work of our analytics where some specific attacks are being analyzed that had happened during this period. Here on the top 2 diagrams, you see similar stuff like previously, only with this client, we had, I believe, 6 different traps. So all the different colors, they are showing the number of IPs and number of attacks on different traps. And here, actually, it is possible to see that the number of attacks depends, number 1, on the network segment where this is placed. And number 2, it also depends on the type of the trap that we are putting there. So if you put enough of those, you can get quite a complete picture even with one client. Now, the lower diagram that you see, I will make it a little bit bigger here. This was with one of our clients recently. The statistics, this is statistics about the number of blocks that are being done by the firewall on the perimeter. So these are quite possibly attempts of attack. Every perimeter device, it has certain blacklists and certain rules that the vendor is providing. But what we are showing here that if you add our threat intelligence feed on top of what the vendor is giving you by default, you can increase the number of blocks at the perimeter. In this case, you see we have here 28% blocks due to our threat intelligence feed. This is how the client has named it. If we are talking about the percentage of increase or in blocks, this relates to some 36, 38% increase compared to the situation where you are not using our feeds. With some clients, these figures are even higher. So this is the second case. Here, the blockings that are due to our threat feed are in orange or brown. It's this 52% that you see here. And just a few months later, after these traps have been in place for a longer time, this has increased already to 75%. This is a extremely good result, probably because this is a huge client. It has so the number of traps deployed there is also quite big, and we can get results like this. Now we are not mentioning here exactly which kind of perimeter devices we are dealing with, but these are the state of the art, the most modern NG firewalls that you have in the market. So 3 or 4 vendors, and even with this, let's say the value that we are providing, it's significant. So most of the IPs that we are seeing on our traps infrastructure, it is not known to these vendors for quite a long time. And all this we are showing during the pilot presentations. Okay, one more view on this. So over a period of a few months, we see that the number of the blocks due to our feed, this is the first here group of columns, is significantly higher than the others. So now what is needed from a client in order to get this working? Literally not much. So this is all that we need. We need a virtual machine created, which will have IP address from the range of IP addresses that the client is using for its perimeter. As you see in point number 2, it's quite modest requirements for this virtual machine. We always insist that this virtual machine is isolated from the internal systems of the client, because this trap is there to be attacked. We are not going to protect it. We're not going to hide it. And this has not happened till now, but in theory, it can happen that it's broken, that it's breached. So in order to minimize any possible negative effect, we insist this is completely isolated from the client's network. We get access to this. We are given access to this virtual machine. If it's a standard trap, within a day, we deploy it here. And we usually deploy 3 or 4 on one virtual machine. If it's a clone trap, so then within a few days, we do the cloning process and we deploy the trap. And this is everything that is needed from the client during the pilot process and later. So it's as simple as that. The second part, as already mentioned, is just configuring the threat intelligence feed on the perimeter firewall, and that is the whole deployment and implementation project. So quite easy, quite simple. The key is to convince the client to do the pilot. After this, it's not very likely that he will not want to have this. So already a certain number of third-party solutions are being used, effectively with our feed, and it is for us not a problem to, in a very short time period, provide integration for any new device. So this is the end of the presentation. I think we have some more time. If there are any questions, if there is something that stayed unclear.
We have one more question. If an attacker decides to target the live system, can your
Yes.
solution detect that attack as well, like an IDS IPS?
Okay. So there are two parts of the answer. First, in what we see in practice. So at the beginning, when the attack is starting, the attacker does not know what is the real system, what is not the real system, and we do not have such cases that only the real system is attacked and the traps do not see this at all. This is first part of the response. For those that are not happy with this first part of the response, there is a second part. So there is also technology of what we call embedded traps. So we can also, embed the trap into, for example, a web server. So embed, it's a phrase that I'm using here, loosely, right? So we can integrate this so that even if the attack appears only on the real system and we don't see it on the traps, which is not very likely, that even then we can react. But what we mostly see in the real world, the attacks, because chronologically how the attack works. First, you have the reconnaissance phase. So they will be scanning. They will not start attacking only your, public service. They will scan the whole perimeter and try to pick an easy target. And as soon as this first phase happens, we will see it on one of our traps. And from that moment on, no other interaction will be allowed with the real systems. The traps will be still there; they will be open to contacts, but the real system will be protected. But as I said, even in this not very likely case, there is technology that can protect from this as well.
Here is one more part of that question in going like that. How much time does the onboarding process take on the average?
So if we are talking about, so the pilot is practically part of the, it's part of the implementation as well. When it comes, there are two parts. There is the traps implementation, there is the integration of the TI feed. So the traps, as I said, from the moment we are given the virtual machine, within a day we deploy the standard traps. Within a few days, mostly a week, we can clone the services that are necessary to be cloned, and we deploy this. Usually in our practice, the client provides the virtual machine anywhere from 1 day to, I don't know, 2 weeks. It depends on how fast the process is going through the IT. When it comes to configuring the perimeter firewall, effectively this takes not more than 15 minutes. In live, again, with all the requests, approvals, and so on, this can take a couple of days. So this is very, very easy to deploy, very easy to start using.
So I can share experience that our company Zebra System has had with AST traps. So no matter that we are not a publicly interesting company, and after 1 month we had over 1,000 attacks, and roughly 100 of those attacks were human based. So that was very, very funny thing.
Yeah. Well, yes, one of those interesting things that people usually like to see is, we are in real time again measuring the, change. How to say, we are inspecting the deviation in the time the attacks happen. So if we have, for example, some automated attack, then you have quite regular intervals, and we are very short between different steps of the attack. If you have bigger deviations and huge pauses and so on, this is most likely a guy sitting somewhere, typing these things into his computer. And so this is the main principle, and we are trying this way to figure out if this is a targeted attack, which is already in some later phase, or this is the regular, scanning and first phases of the attacks.
Yeah, maybe you can give us some more information. Can you share with us experience what kind of customers are interested in this kind of advanced solutions, like maybe governmental or financial sector, or industry, or maybe.
Yes. Well, there is a general response which says that you have, as a rule, types of organizations that are interested and can afford information security solutions in general, right? So here we are able to a little bit expand this potential target audience, because the cost of this system uh, can be adjusted to also not so big budgets of smaller companies. But when it comes to threat intelligence, this is usually the target customers can be banks, can be government organizations, this can be corporations. So similarly to the first answer, companies that can afford and they are aware of something like this. For them, usually it's why we are insisting on a pilot, because their logic is the following: I already have a solution that is protecting me on the perimeter, right? So it's one of the Gartner vendors that I have here. So I'm covered. And after pilot, when they see that they are not really covered and they can actually improve the protection by huge percentage compared to what they have at the moment, then they become interested. When it comes to national threat intelligence, of course, the very word explains who might be a potential interested party for this. So usually it can be some government or state cert, or it can be some security companies that are interested in analytics, or it can be government organizations. But usually when we are talking about national threat intelligence, we are trying to find a single partner who is interested in doing this globally on the national level. So more or less like this. So I would say traps, this is more in the and the related TI. You can offer this also to smaller companies. The thing is how security aware they are, but the budgets can be also adjusted to small and medium business. But of course, corporations, government organizations, semi-government organizations, financial industry, these are the main point of interest for us.
Yeah, that's definitely.
By the way, Nebashir, if you give me one more minute, I will just also quickly mention. Yes, I was talking about the Log4j, for example. So this is in our world of information security. This was a huge event, 2 years ago, because it left everybody unprotected. And what we proudly now analyze, backwards and talk about, is that even before the public disclosure, we have seen some of these attacks on our traps, and this allowed us to make our clients protected from these attacks. Also, as early as in the zero-day attack phase. So the whole world just found out that something like this exists. Our clients were already protected. This is the part about the unknown, about the zero-day attacks, where we also provide huge value. And I remember now my first encounter with the solution, because as I said, I'm from the services part of the company. Usually my colleague Vladan does this kind of presentation, so I'm trying to fill in his shoes today, and which is not easy, by the way. And the first moment I've seen this technology, it was some 4 years ago, I think. And we are doing a demo for Security Operations Center for one of our clients, and we had also a previous version of the world map. Back then, the number of attacks was not so big, so we had really real time displaying of the attacks on the screen. Now we only do it once in 10 seconds because there are so many attacks that you cannot update this all the time. So what we were seeing every day is, for example, I don't know, the dynamics of, for example, 1 dot per second was, lightning on this map. let's say once you see here, then in the next second you see somewhere else, it means that the attack took place. Yeah, so this was in the early phase.
Did you mean to share your screen with us?
This I cannot share. This is
no problem. I just wanted to be sure that that you maybe
yes
do not miss the point. No
I'm
problem.
not. And what happened once, we came to work in the morning, and what we saw on the screen, it was flashing. It was flashing all the time. So it's incredible. It's like we had probably, I don't know, 10 these attacks per second. So something strange was happening. And once the analysts, got to work and they started working on this, it turned out that this was actually it was not yet zero-day vulnerability. It was unknown attack, but we saw that it was happening on Microsoft SQL Server, and the guys already started analyzing what was happening. And a couple of days later, we had the CV published, and so on and so on. So what I want to emphasize this: the approach works. It seems to be quite simple, but it requires all of these building blocks to be done, very well in order for all this to work together. But it works and it brings real value. So this value can be measured, and it can be easily shown during the pilot project. So we have really big hopes when it comes to this technology.
That's really great. I just wanted to remind everybody, talking about you taking Vladan's shoes, I just want to mention that nobody left the presentation, which is a huge sign that you really fit the shoes, which is great. And I really enjoyed the presentation. I just wanted to mention all those vectors of attacks are actually related to motivation. It's different type of kind of motivation is in the back, like several years ago with crypto, when attackers invented crypto currencies as a method of ransoming people. Then we saw explosion of ransoming, but now they're looking for new, how to say, ways to use attacks to fulfill some other motivations, like political, like even some attacks in decent past were religiously motivated. So it's a scope of utilization of attack to achieve some goals is wider and wider. And I wouldn't be surprised that even churches start asking for firewalls and so on.
Yes.
So I wanted to do last check for some questions. Is there any more questions or any initiative? Any type of initiative you can address on AST or on Zebra, if you have, and we can start from that. So from partners' perspective, not much is necessary from technical knowledge to be able to participate in projects. And I strongly believe that there is a lot of space to put AST solution as additional layer, which could be glue for existing technologies, no matter how good they are, and bring value on both sides.
Yes, I agree completely. So the key point is, if there is a way to persuade the client to do the pilot, I think the technology will do the rest. So if there are potential prospects, so please come to us with this, and we will see how we proceed. And again, the revenue sharing model, our experience is that it guarantees satisfaction on on all sides. So this is, for us, this is the way to do.
Uh,
I'm just, I want to thank everybody for the attention. If there are additional questions, we are open to this at any time. Nebojša, also thanks a lot for the opportunity.
Just one note. In this moment, we have several ongoing negotiation with partners and potential customers in the region. I'm thinking in Czech, Slovakia, and Adriatic. Some even one on a state level, and two with very strong industrial subjects. So we have even experience in our region. They are proven customers in Europe, Asia, which are from huge to small to medium, and government, even ministries of forces like the Ministry of Defense or Ministry of the Interior. Okay, it was really a pleasure to have you on this presentation, and many people greeting you. And once more, thank you, George, for your participation. It was a pleasure have you on this call.
My pleasure. Thanks a lot.